Hi! So today in this video we're going to be covering chapter 3.1.1, which is an introduction to polynomials. And there are a few things to keep in mind when we're talking about polynomials. And the first thing is going to be terms. And not terms like vocabulary. When we're talking about terms in math, we're talking about basically say you have a polynomial that's like 3x squared plus 4y plus 2x plus 8y plus 4x cubed. Say we have this. Terms are separated by addition or subtraction. We'll change this to a subtraction to make things easier. Terms are separated by addition or subtraction, and they also have the same variable with the same exponent. So for instance, this 4y and this 8y, these are the same terms. And that means that we can add or subtract them together. So our new equation would look like 3x squared minus 4y, because 4 minus 8 is negative 4y, and then plus 2x plus 4x to the cubed. Now, you'd think that, hey, these all have x's, right? They are not like terms because they do not have the same exponents. You can have terms that are like 4xyc squared or 3x squared y third c, stuff like that. And if they're like terms, they have to have all of the same variables with all of the same exponents. Another thing to know, you also can multiply different terms. So you could have 3x times 4y x squared, and you could multiply these terms together. First, you'd look at the common things. So we have our coefficients, the coefficients are the integers connected to our variables. They're like 3 or 4 or 15, anything that's a number. So we'll multiply these together first, and that will give us 12. Then we look at the x's, and that will give us x cubed, and then we add the y. The only thing that really multiplies are the matching things. There's also the concept of ascending and descending order. Just descending order. Descending order looks at the term with the highest exponent on it. And in this case, it's 4x cubed. And then we'll find the one that's next to it, so 3x cubed, squared. And then it's a toss-up for these. I would put the x's next to each other, so plus 2x minus 4y. You'll typically only see ones that have the same variable, like x. And then we also want to learn about the degree of a term. Degree of a term and then degree of a function. Now, the degree of the term, the degree of a term is basically the exponent. So in this case, 4x cubed is our degree. So this term, 4x cubed, is degree 3. And then this degree would be 2. This degree would be 1. If it's something like just like 3, that would have the degree of 0. And then if you have something like 3x squared y, the degree of this term would be 3 because we're adding these two degrees together. Now, when we're talking about the degree of a polynomial, it's going to be the highest one, the highest degree term. So we won't add all these degrees together to find the degree of the term. All we look at is the leading coefficient, which is the leading coefficient is this 4 here. And then we want to look at the leading term, which has the highest degree. So this polynomial is a polynomial to the third degree. Some more things to know is the terms, not the vocabulary terms. Now we're not talking about terms. So a monomial, like a monogram, is a polynomial that has only one term. So this would be a monomial. A binomial has two terms. Binomial. binomial. So that would be something like 4x cubed plus 3x squared. This would be a binomial. A trinomial has 3 terms. So something like 4x cubed plus 3x squared plus 2x. This would be a trinomial. And a polynomial is anything that has 4 or more terms. So polynomial. Another thing to note is when we're thinking about polynomials, we cannot have any decimal exponents. So we can't have anything like 4x to the 1/3 or 4x to the 1.7 or anything like that. We can't have anything like that. They have to be integers. And we also cannot have negative exponents. So we can't have anything like 4x to the -3rd. That's not allowed in polynomials. And we also cannot have any x's in the denominator. So anything like 3 over x squared, that's not a polynomial. Those are some things to keep in mind. And then let me see if there are any other terms that are needed. A constant is a term that has no variable. So oftentimes you'll see something like 3x squared plus 4x minus 5 or something like that. The constant of this equation would be this -5 because it is not attached to any variable. Again, the leading coefficient is the term that has the highest exponent, the highest degree, but it's only like this thing, like the leading coefficient would be 3 in this case. The leading term would be this whole thing right here, but the leading coefficient is this 3. I believe those are the terms that you need to know. So now we'll get into some of the problems that you'll see on Lumen. This one is asking us how many terms are in the expression 4x plus 2x to the 5th minus 5x cubed minus x squared minus 3. Now, this is a term, this is a term, this is a term, this is a term, and this is a term. So we have 1, 2, 3, 4, 5. We have 5 terms in this polynomial, in this expression. Which of the following terms are like terms? So this one is when they have the same exponent and the same variable attached. So it looks like the recurring theme is x to the 5th. So we want to find any that has x to the 5th. So this one has x to the 5th. We have negative 3x to the 5th. Y to the 4th is not. 5s to the 5th is not. T to the 9th is not. Negative 2x to the 5th is, this one's not. 6x to the 5th is, and this one's not. So we just want to find ones that are matching. Now this one's telling us to match each term to its like term. So again, that's when we look at the variable and the exponent and we say which one is the same. So this one has an x squared and this one has an x squared, so these will be matched. This one has an xy and this one has an xy, so these will be matched. This one has just a sole x and this one has a sole x, so these will be matched. This one has an a and this one has an a, so these will be matched. And this one has no variable and this one has no variable, so we'll go up there. And this would be your answer. More accurately, you'd be like, this is A, this is B, this is C, this is D, and this is E. Yeah. Now this one's telling us to select all of the expressions that are polynomials. Now when I was looking through gathering problems for this example, I was confused. I was like, I think all of these are polynomials because they all have lots of terms. But then I remembered that number one, we cannot have any negative exponents, and we also cannot have any fraction or decimal exponents. So, or any exponents in a denominator, any variable in the denominator. So this is not a polynomial because we have an x in the denominator. This is a polynomial because all of them are integer exponents and there are no x's in the denominator. This one is not a polynomial because there's a negative exponent. This one is not either because there's a 1.6. And this one is not because this is 3/4. So it's only this one that's a polynomial. Now this one's telling us to, for each of the algebraic expressions below, select the name that best describes the expression from the list of choices. Now this one, it'll ask you, is it a polynomial, a binomial, a monomial, a trinomial, or none? Now this one has 4 terms. We know that anything that has 4 terms or above is a polynomial. This one has an x in the denominator, so we actually are not allowed to call that a polynomial. This one has 2 terms, so it's a binomial. This one only has 1 term, so it's a monomial. And this one has 3 terms, so it's a trinomial. This one wants us to answer the following questions. Find the degree of the terms, and then find the degree of the polynomial. Now, the degree of this first term, since there's no variable, will just be 0. The degree of this one will be 5, because the exponent is 5. The degree of this one will be 2, and the degree of this one will be 4. And the degree of the polynomial is going to be the largest one, so it's going to be 5. And then the polynomial function, find the degree of the polynomial. This one will be 6, because that's the largest one. Whoops. This one is asking us to find the degree, leading coefficient, and the constant term of the polynomial. Now, if you remember, the degree is going to be the highest, so 7 is our degree. Our leading coefficient is the number that's attached to our highest degree term, so it's going to be 4. And the constant is going to be the one with no variable attached, so it's going to be 6. Final question, we have select all of the polynomials that are written in descending order. Descending order, if you remember, is going from biggest to smallest when we're talking about the degree of our exponents, of our terms. So this one is in descending order because it goes 12, 11, 9. This one is because it goes 11, 9, 8, 2. This one is not because it goes 9, 2, 8. This one is not because it goes 11, 2, 7. This one is because it goes 8, 7, 2. And this one is not because it goes 7, 2, 12, 11, and 9. And that's not in order. Now, if you have any questions, please let me know, and I will answer as soon as possible. Have a good one.